Very good morning, friends. Myself, Professor M. A. Chennaya, and in today's video, we are going to study about the development of lateral surface of a triangular pyramid, which is cut by two section planes, and both the section planes are normal to VP, perpendicular to VP, and very obviously they will be seen as lines in the front view, and one of them is horizontal, other is inclined at an angle to HP. It says at an angle of 45 degrees to HP, and says, friends, in the initial position, the pyramid is resting on HP on the base ABC, such that one of the base edge is parallel to VP and nearer to it. So friends, I am going to write down the top and front views of the pyramid of size 30 mm. So I will take this side as 30 mm, complete the top and front views. Friends, here exactly through this corner you will have the vertex of the pyramid. The height of the pyramid is given to be 60 mm. So I take 60 mm height, obtain O dash, the vertex. We will name this as ABC. This is A, this is B, and this is C. And these are the slant edges OA, OB, and OC. OA, OB, and OC. And here we will project these points and obtain on XY the points A dash. This is C dash. Also O1 dash is here, and this point is B dash. We will join the center, the vertex to all these corners, O dash to A dash, O dash to B dash, and O dash to C dash. So the base is A dash, B dash, C dash. The vertex, it is O dash, and here we will show by O1. This point represents the axis in the top view. Friends, we have drawn the front view and top view of the pyramid, which is resting on the triangular face with AB, means one of the shorter edges or the base edge. AB is parallel to VP and nearer to it. AB is parallel to VP and also it is nearer to it. It is cut by two section planes, both being normal to VP, and they intersect at the midpoint. So we will locate the midpoint of the axis at a height of 30 mm, that is midpoint of O dash, O1 dash, and from here we will draw two section planes. One of the section plane is horizontal, say this is 1 1, so I'll call it as 1 1 is one section plane. Other one is inclined at an angle of 45 degrees to the axis. So friends, I will write down the second section plane passing through the same point. We'll call it as 2 comma 2, section plane 2 2, which is inclined at an angle of S2 is section plane 2, S1 is section plane 1. It is at an angle of 45 degrees to the horizontal. So friends, here it says in the question, draw the development of the lateral surface of the lower part of the pyramid. Which is the lower part? The part which is here, that is this part. I am going to show by full line. These are the slant edges and this is the base, and this is how the object is being cut here. Now friends, I want the development of this bottom portion, that is from this point till here, this portion. I need to draw the development. And friends, as usual, assuming it is not cut by any section plane, let us obtain the development of this, in which you are going to have three isosceles triangles. There will be three isosceles triangles here. Now friends, we how to get the true length? Friends, if you observe the slant edges O dash A dash, O dash C dash, O dash B dash, and the corresponding top view OA, OB, OC, none of these slant edges are parallel to XY or parallel to VP. So you know very well all the developments are to be drawn to true size. So what we do, keeping center O and radius equal to the radius OB, we draw an arc to cut the horizontal line drawn through this at this point. So I am going to take this as center, this as radius, draw an arc. So and from this point we will project upwards and get a point here. That means I have made OB parallel to VP, and hence this O dash B1 dash, say B1 dash will give you the true length of the edge. So I will say this is true length. So this construction is very important, and if you don't make this construction, you don't get any marks at all. Now friends, with this O dash B1 dash true length, this is our O, and taking that as the true length, we are going to have three parts made here. That's 30 mm an arc, 30 mm, 30 mm, and I am going to join all this by straight line. So all this will be joined by straight line. So this is the second part of the base. This is the third part. You remember all these are having dimension 30. The radius of that arc is 30 mm. We will join them by thin lines to start with. A thin line here, another thin line here. Friends, you have got the development of the triangular pyramid drawn, assuming it is not cut by any section plane. Now friends, let us see from where we have to start the development from. Is it from OA or OB or OC? Friends, here none of these slant edges, either OA, OB or OC, are totally removed, and hence friends, you have the choice of starting this development either from OA or OB or OC. So friends, the choice is ours. Now what I do friends, I'll say I will start with this OC, and end with that C. So this is going to be A, this is going to be B. So A, B, C, the first and the last will have the same marking. Now let us take section plane 1, 1 to start with. This section plane is horizontal. It is cutting the slant edge O dash A dash at this point. But O dash A dash is not the true length because it is at an angle to VP in the top view. So I am going to transfer this point on OA to this, that is to this point, and measure this length, transfer it to OA. Where is OA? This much is to be taken on OA. So suppose it is almost at the center, we take a point OA there. Then friends, it is cutting this edge, that is it is meeting at on the line OC, but OC is also not the true length. So I have to transfer that to the true length, mark the same measurement on OC, the second slant edge, and also here you have to mark OC because there are two times OC drawn. And then friend, OB is cut here. OB is also, O dash B dash is not the true length. Hence, we have to transfer that to the last line, O dash B1 dash. Take that measurement on OB, the slant edge OB. Say we are getting here. So we got 4 points, friend. But what has happened here? These section planes S1 and S2 They intersect at the midpoint of this AB, the edge AB. You can just observe here, exact at the midpoint, they are intersecting. So we have to get a point for that also. How to get that, friend? So friend, here, you got AB here, you mark the center and draw a line through that, a thin construction line through that. And on that, what is the point you should take? This is same as this we are taking on this OB, that is on point OC. Whatever the height you have got, you should take there. That means this length, this length, and this length, including this, are the same. So friends, we have got so many points, and let us name those points as 1, 2, 3, 4. 1, this is 2, this is 3.4, and on this OC again 0.1, because when you fold them together, you should get like this. Friends, you join all this now. So 1 to 2, 2 to 3, again it is same line only. 2 to 3, then 3 to 4, 4 to 1. So these are the points where the two section planes are cutting the solid. And you can observe the full base ABBCCA is intact, not touched by the section plane. Hence I am going to mark that by full line. And 2 and A, this is point 2 and A. It is existing. This is only construction. Please don't join this. And this is intact. This line is also intact. And we have these base edges. One here, the second one, because the base is totally intact and you are going to get the development. So let us join this 2 to A also. And here we are not supposed to join because only there should be 3 triangles. 1, 2, 3. And this is how we get the development for this part, the lower part, which we call it as P. And this colored portion, whatever done here, will give you development of P, and P is the lower part of the pyramid. And friends, I hope you are happy with the presentation I have made, and this is one of the beautiful questions generally asked in the examination. And if you are happy with the presentation I have made on this particular problem, please give a liking, share the information with all your friends, and have a wonderful day. And this is Dr. M. A. Channaya signing off.